Okay, so there's a control volume for part B, and part B asks us the time taken to discharge 50 cc's of oil. Okay, we were given that value for the first part of the question, 167 seconds. Okay, would you expect it to be higher or lower than the time than A? Well, if we look at the geometry of the problem and physics, you can see that now we have the mass of the fluid in this control volume acting vertically downwards due to gravity. Okay? Exactly the same pipe dimensions. Okay, same diameter, same length. So we're looking for an answer for part B less than 167 seconds. Okay? Looking at our control volume now, again we have this pressure difference, which is delta P, so exactly the same term, okay, acting downwards, plus weight of the fluid, okay, an additional force acting downwards, opposed by, again, this wall shear stress term multiplied by that internal surface area. Okay, so we can write out a very similar expression but with this additional term in it. Okay, and then the process is almost the same. We're asked to find the time, so the continuity element of this question is going to come in at the end rather than at the beginning, which we had with part A. Okay, so I've written out the expression for our force balance. Again, the pressure term acting downwards, delta P, times the cross-sectional area, plus the mass term of the fluid in the control volume acting downwards, so rho G times the area times the length of the tube. Again, units of force in all three terms, and then to finish, same expression again for the opposing force, so the wall shear stress times that area. What we're going to do now is rewrite this in terms of tau, as we did before, and then again we know that the friction factor equals 16 over Re, so we're going to work through, but this time we're going to solve for the value of U, okay, because we already know the value of the dynamic viscosity, okay, from the previous part of the question. Okay, so this is our new expression. I'm going to do the same thing again. F equals 16 Re equals shear stress over half rho U squared. Okay, so we can exactly the same process as before, but now we're going to substitute in for this value of tau W, and also Reynolds number, and we're going to solve this time for U, the velocity. If you rearrange that expression for a value of U bar, you get this expression here. So have a go at rearranging and simplifying it. Work it through. This is your value of velocity that you should get out. Then just apply continuity. Should be fairly simple to do. Again, time taken for 50 cc's of oil to drain through, so 50 times 10 to the 6. And we can work out Q equals U times A. Okay, so we should be able to work out the time. And that comes out at 111 seconds. Okay, so I guess the key message is, firstly, when you see one of these problems, is to start to fill in the blanks. The first part, part A, that's very important. We know we need velocity. It's a question about a viscous fluid. We've not been given it, So it's a given we need to work out the velocity. Okay, we're told it's laminar flow. Okay, so we understand that friction factor is 16/RE, which is given in the question. Okay, so you need to expand Reynolds number out to those four terms. One of them is the viscosity, which is what we're aiming for. Okay, so you can hopefully see the route through. Oh, and obviously remember, draw your control volume out and look at the balancing forces. If in doubt, check the dimensions of each force term to ensure they are actually a force. Okay, with part 2, part B, same thing, but the continuity part comes in right at the end. Okay, we already know the viscosity, so we're now solving for the velocity. Don't forget that we have the additional weight force of the fluid acting downwards, so we get a slightly more involved expression, but exactly the same methodology. You rearrange that, substitute in, rearrange that for u, calculate u, and it's a short hop to work out the time.